Yes, 15 kilovolts distribution has been implemented in floating marine environments. Several marinas have successfully adopted this approach to deliver power to their vessels. Consider Marina del Rey, California, where a 15 kilovolts distribution network caters to more than 5,000 boats. Then there's Newport Beach, California, another example of a marina utilizing 15 kilovolts distribution to serve over 10,000 boats. St. Petersburg, Florida also employs a 15 kilovolts distribution system, providing power to over 2,000 boats. These marinas demonstrate that 15 kilovolts distribution can be a dependable and economical method for supplying power in such settings. However, before implementing a 15 kilovolts distribution system in a floating marine application, several crucial factors must be carefully evaluated. Firstly, safety is paramount. Given that 15 kilovolts is a high voltage, ensuring the safety of personnel and equipment is of utmost importance. This necessitates employing appropriate grounding and bonding methods and incorporating protective devices such as circuit breakers and fuses. Grounding and bonding are essential for minimizing electrical hazards. Grounding establishes a low impedance path for fault currents, allowing protective devices to quickly trip and energize the circuit, thus preventing electrical shock hazards. Bonding, on the other hand, ensures that all metallic parts are at the same potential, reducing the risk of electric shock if someone comes into contact with two different metallic surfaces. The selection of circuit breakers and fuses should be based on the calculated load and the interrupting rating of the devices. Circuit breakers are recessable and can be used to protect against overloads and short circuits. Fuses are one-time use devices that provide overcurrent protection. The National Electrical Code, or NEC, provides guidelines for selecting the appropriate size and type of circuit breakers and fuses for different applications. Secondly, corrosion is a significant concern. The marine environment's corrosive nature requires the use of corrosion-resistant materials. Stainless steel or aluminum for conduits and fittings, along with copper or aluminum for conductors, are advisable choices. Corrosion can degrade the performance of electrical components and lead to failures. Stainless steel and aluminum are more resistant to corrosion than other materials such as steel. Copper and aluminum are excellent conductors of electricity and are also relatively resistant to corrosion. The NEC specifies the types of materials that are suitable for use in marine environments. Thirdly, maintenance is essential. 15 kilovolts distribution systems necessitate routine maintenance to guarantee safe and reliable operation. This includes equipment inspections, circuit testing, and replacement of worn or damaged components. Regular inspections can identify potential problems before they lead to failures. Testing circuits can verify that the system is operating within its design parameters. Replacing worn or damaged components can prevent breakdowns and extend the life of the system. A comprehensive maintenance program should be developed and followed to ensure the continued safe and reliable operation of the 15 kilovolts distribution system. The frequency of maintenance activities should be based on the manufacturer's recommendations and the operating conditions. The NEC provides guidance on the maintenance of electrical systems. In summary, 15 kilovolts distribution can be a viable option for powering floating marinas. Prior to making a decision, it is crucial to thoroughly assess the safety, corrosion, and maintenance implications. A well-designed and properly maintained 15 kilovolts distribution system can provide a reliable and cost-effective power source for floating marinas. Further elaborating on safety measures, it's imperative to adhere to stringent safety protocols during installation, operation, and maintenance. Qualified personnel trained in high-voltage systems should handle all aspects of the 15 kilovolts distribution network. Proper personal protective equipment, or PPE, including insulating gloves, sleeves, and safety glasses, must be worn when working on or near energized equipment. Lockout/tagout procedures should be implemented to energize equipment before performing any maintenance or repairs. Warning signs and barriers should be used to restrict access to areas with energized equipment. Emergency procedures should be in place to address potential hazards, such as electrical shock or arc flash. Regular safety training should be provided to all personnel involved in the operation and maintenance of the 15 kilovolts distribution system. Delving deeper into corrosion mitigation strategies, several approaches can be adopted to minimize the effects of the marine environment. Firstly, cathodic protection can be employed to protect metallic structures from corrosion. Cathodic protection involves applying a direct current to the structure, which makes it the cathode in an electrochemical cell. This prevents the metal from dissolving and corroding. Secondly, coatings can be applied to protect the metal from exposure to the corrosive environment. Coatings can be paints, epoxies, or other materials that create a barrier between the metal and the environment. Thirdly, corrosion inhibitors can be added to the water to reduce the rate of corrosion. Corrosion inhibitors are chemicals that react with the metal surface to form a protective layer. The selection of the appropriate corrosion mitigation strategy depends on the specific application and the severity of the corrosive environment. Providing more details on maintenance practices, a comprehensive maintenance program should include regular inspections, testing, and component replacement. Inspections should be conducted to identify any signs of corrosion, damage, or wear. Testing should be performed to verify the proper operation of the system, including insulation resistance tests, circuit breaker testing, and transformer testing. Components should be replaced as needed to prevent failures and ensure the continued safe and reliable operation of the system. A detailed maintenance log should be maintained to track all maintenance activities. The maintenance log should include the date of the maintenance, the type of maintenance performed, the results of the maintenance, and the name of the person who performed the maintenance. This information can be used to identify trends and predict potential problems. Diving further into the NEC requirements, Article 555 addresses the installation of electrical wiring and equipment in marinas and boatyards. This article provides specific requirements for grounding, bonding, wiring methods, and overcurrent protection. Section 555.3 specifies the requirements for grounding and bonding. This section requires that all metallic parts of the electrical system be bonded together to form a continuous electrical path to ground. This is to prevent electric shock hazards. Section 555.4 specifies the requirements for wiring methods. This section requires that wiring be installed in a raceway, such as conduit, or be identified for use in wet locations. This is to protect the wiring from the corrosive marine environment. Section 555.7 specifies the requirements for overcurrent protection. This section requires that overcurrent protection devices, such as circuit breakers and fuses, be installed to protect the wiring and equipment from overloads and short circuits. These are just a few of the NEC requirements that apply to the installation of electrical wiring and equipment in marinas and boatyards. It is important to consult the NEC for all applicable requirements. Consider the specific requirements for 15 kilovolt systems. These systems require additional safety precautions due to the high voltage. Personnel working on 15 kilovolt systems must be qualified and trained in high voltage safety procedures. Equipment used on 15 kilovolt systems must be rated for the voltage and current. Grounding and bonding must be properly installed to prevent electric shock hazards. Regular inspections and maintenance are essential to ensure the safe and reliable operation of the system. In addition to the NEC requirements, there may be local codes and regulations that apply to the installation of 15 kilovolt systems. It is important to consult with the local authorities to ensure that all applicable requirements are met. Addressing the design aspects, designing a 15 kilovolts distribution system for a floating marina requires careful consideration of several factors. Firstly, the load requirements must be accurately determined. This includes the number of boats, the size of the boats, and the types of equipment that will be used in the boats. Secondly, the voltage drop must be minimized. Voltage drop can reduce the performance of equipment and lead to overheating. Thirdly, the system must be designed to withstand the corrosive marine environment. This includes selecting appropriate materials and using corrosion protection methods. Fourthly, the system must be designed to be safe. This includes providing adequate grounding and bonding and using protective devices. Fifthly, the system must be designed to be maintainable. This includes providing access to equipment for inspection and maintenance. Regarding the economic aspects, the cost of installing a 15 kV distribution system can be significant. However, the long-term benefits may outweigh the initial cost. A 15 kV distribution system can provide a reliable and cost-effective power source for floating marinas. It can also reduce the risk of power outages and improve the overall efficiency of the marina. The cost of a 15 kV distribution system will vary depending on the size of the marina, the load requirements, and the complexity of the system. It is important to obtain multiple bids from qualified contractors before making a decision. In conclusion, the use of 15 kV distribution in floating marinas is a viable option that offers several advantages. Firstly, it provides a reliable and cost-effective power source, ensuring a consistent supply of electricity to boats and other equipment. Secondly, it minimizes voltage drop, which is crucial for maintaining the performance and efficiency of electrical devices. Thirdly, it can handle large power demands, making it suitable for marinas with numerous boats and heavy electrical loads. However, it is crucial to address the challenges associated with this approach. Firstly, safety is paramount, and stringent measures must be implemented to protect personnel and equipment from high voltage hazards. Secondly, corrosion is a significant concern in the marine environment, and corrosion-resistant materials and protection methods must be employed. Thirdly, regular maintenance is essential to ensure the continued safe and reliable operation of the system. Before implementing a 15 kV distribution system, a thorough assessment of the specific needs and conditions of the marina is necessary. This includes evaluating the load requirements, the environmental conditions, and the available resources. A detailed design should be developed that addresses all safety, corrosion, and maintenance considerations. Qualified personnel with expertise in high-voltage systems should be involved in the design, installation, and maintenance of the system. By carefully considering these factors, marinas can successfully implement 15 kV distribution systems and reap the benefits of a reliable and efficient power supply. Lastly, let's cover some practical considerations for implementing 15 kV distribution in a floating marina. Firstly, consider the physical layout of the marina. The location of the substation, transformers, and distribution lines should be carefully planned to minimize voltage drop and ensure easy access for maintenance. Secondly, select equipment that is specifically designed for marine environments. This includes transformers, switchgear, and cables that are resistant to corrosion and moisture. Thirdly, use proper grounding and bonding techniques to minimize the risk of electric shock. All metallic parts of the electrical system should be bonded together and connected to a grounding electrode. Fourthly, install surge protection devices to protect equipment from voltage surges caused by lightning or other events. Fifthly, develop a comprehensive maintenance plan that includes regular inspections, testing, and component replacement. The maintenance plan should be tailored to the specific equipment and operating conditions of the marina. Sixthly, train personnel in the safe operation and maintenance of the 15 kV distribution system. Personnel should be familiar with the potential hazards and the proper procedures for working on or near energized equipment. By addressing these practical considerations, marinas can ensure the safe, reliable, and efficient operation of their 15 kV distribution systems. Ultimately, the decision to use 15 kV distribution in a floating marina depends on a variety of factors, including the size of the marina, the load requirements, the environmental conditions, and the available resources. However, with careful planning, design, and implementation, 15 kV distribution can be a viable and beneficial option for powering floating marinas.